On January 6, 2025, at 11:15 in the morning, a man was enjoying his usual view of the Pacific Ocean from his apartment balcony. It was a peaceful, ordinary day until he noticed sparks and flames emerging from the hills of Pacific Palisades, around 5 miles away. Within an hour, the fire had spread rapidly, with smoke engulfing the hills entirely. Satellite images confirmed that the fire started in the Palisades Hills, but quickly spread to nearby areas such as Eatonhurst, Kenneth, Getty, Skirball, and San Fernando. At the time, the winds were blowing at speeds of up to 100 kilometers per hour, moving from inland toward the ocean. But here's the question. If the fire started in the Palisades, near the ocean, how did it spread 30 to 40 kilometers in the opposite direction, against the prevailing winds? This fire would go on to devastate a total of 38,000 acres, approximately 150 square kilometers, destroying 12,000 buildings and displacing 180,000 people. Despite the efforts of firefighters, including water bombers dropping 45,000 liters of water at a time and special chemicals to suppress the flames, the fire remains largely uncontrollable. California, already dealing with water shortages, often has fire hydrants that are either empty or insufficient to combat such massive fires. The fire spread across 7 distinct areas, dividing the firefighters' efforts and resources. Moreover, the winds continued to blow at speeds of 70 to 100 kilometers per hour, making the fire even more difficult to control. To understand how this could happen, we must take a look at California's history of wildfires over the past 25 years. In 2003, the Cedar Fire in San Diego County burned 273,000 acres. It started on October 25th and was extinguished by November 4, 2003. In 2017, the Tubbs Fire destroyed 36,000 acres in October. Later that same year, the Thomas Fire consumed 280,000 acres. On November 8, 2018, the Camp Fire scorched 500,000 acres in just 17 days. Then, in 2020, the Glass Fire burned 67,000 acres, starting in September and ending in October. One common factor in all of these fires is that they all occurred in winter. Similarly, the Los Angeles wildfire began during the peak of winter. So, why do most of California's wildfires happen in winter? The answer lies in a natural phenomenon known as Santa Ana winds. Santa Ana winds are warm, dry winds that blow through Southern California and Baja California, particularly during the autumn and winter months. Geographically, east of California lies vast desert land, including the Mojave Desert and the Great Basin. The sun's intense heat warms the desert, causing the air pressure in the region to increase. On the other hand, the ocean's cooler air has lower pressure. As we learn in basic science, air moves from areas of high pressure to areas of low pressure. The greater the difference in pressure, the faster the air moves. In this case, warm, dry winds from southeast California, Santa Ana winds, rush toward the ocean. As these winds pass through regions, they absorb all the moisture, leaving the areas extremely dry. Vegetation and trees become highly flammable due to this extreme dryness. Santa Ana winds essentially turn the landscape into fuel for wildfires. If a fire starts accidentally, these winds act as accelerants, rapidly spreading the fire. Burning embers travel quickly, making the fire nearly impossible to control. Wildfires generally spread in the direction of the wind, but the Los Angeles fire defied this expectation. Though the fire initially broke out near the Pacific Ocean in the Palisades area, it later spread inland, away from the ocean and against the wind. To understand how this happened, we must explore a fascinating natural phenomenon called the maritime mountain wave rotor. When winds blow toward a mountain, the side of the mountain facing the wind is called the windward side. The opposite side, which faces away from the wind, is called the leeward side. Winds hitting the windward side of the mountain create a vortex effect on the leeward side, where the wind begins to spin in a circular motion. This causes a reversal of wind patterns below the mountain. While the winds above the mountain blow in one direction, the winds below can flow in the opposite direction. In the case of Los Angeles, the Palisades area is on the leeward side of the mountains. Due to the mountain wave rotor effect, the winds there were reversed, pushing the fire inland rather than toward the ocean, as one might expect. This phenomenon helped explain how the fire spread 30 to 40 kilometers against the wind. As wildfires continue to ravage areas, their frequency is increasing due to the effects of climate change. Fortunately, modern technology and artificial intelligence are now helping predict the direction of wildfires. Firefighters receive this information to assist in their efforts to combat the fires, although it often feels like a losing battle.